but we're standing on the shoulders of giants when we're talking about systems influences. There was a chap in the 50s named Lovelock who talked about the Gaia. And he was published in Nature a number of times. He's referred to by many people. He started a whole movement of argument. And he points out that everything in Earth is linked to everything else. There's a bias there. All living things are connected and dynamic across whole of Earth. And an American lady, Rachel Carson, she talked about natural systems are altered by human behaviour, particularly pesticides and chemicals and so on. But her great contribution, and she was vindicated in the North American legislature at the time, is that, your actions as a human being do actually impact on natural systems, so you can make a difference. Jay Forrester was a professor of economics at MIT, and he wrote the world systems models, and he highlighted that Earth's dynamic systems include human behaviours, and into the future, which we're discovering now, human behaviours can actually alter the course of Earth's systems. For instance, climate, health of waterways, availability of water. Donella Meadows, her last publication that was published after she passed away, and she was from the Rocky Mountains Institute. Before that, she wrote the Limits to Growth books. She was a student of Forrester, so linked back to MIT. Her big life discovery is everything is driven from the small scale to the big scale. And you might say, yes, of course. Well, no, because all of the theory across most sciences and engineering disciplines and economic disciplines is the opposite. Everything's average. It's driven from the top down, from the big scale. And Meadows' final insight in a life of being a systems thinker is, everything's driven from the bottom up. So if you change things, like you change your behavior, you harvest rainwater, you change the way you use packaging, you use less plastic, whatever. Mm-hmm. If you do it, it accumulates through the system if others are doing it, and it changes the system. And she found that it's far less likely, if you assume everyone's average and you try and change the system from the top down. Her life's work showed changing things from the top down doesn't work very often. And of course, we've got the International Climate Change Panel that's now showing that Earth systems and human welfare are impacted by climate, and we impact on climate, so doing things locally produces global benefits. And then we've got Nobel Prize winning economists such as John Nash, and you've got a chap named Coase from England, who realised via their decision theory and game theory research that everything is driven by decisions at the bottom, at the local scale, not the top scale.
I just picked up the Donella Meadows book based on your recommendation, and from the cover, I was quite... here's what it says. It says, some of the biggest problems facing the world, war, hunger, poverty, and environmental degradation, are essentially system failures. They cannot be solved by fixing one piece in isolation from the others, because even seemingly minor details have enormous power to undermine the best efforts of too narrow thinking. So that's from her. That's from the back cover of her book.
And when you think about that, is so correct. And sorry, Michelle, an example. When I was doing my postgraduate research, we had a systems guy come in who just happened to be an advisor to a number of governments and the UN and the World Bank. And he gave the Aswan Dam example in Egypt, I think, or the Middle East. And he said they worked out, this dam will benefit everyone and it'll really be great. And what it did is decimate farming areas, because it actually changed the transfer of nutrients down the river system. because before they had the dam, the farmers relied on their properties being flooded once a year to deposit nutrients to replenish the soil system so they could grow crops the following year. But they built the dam to stop the flooding, and it was a great society benefit. But they didn't think about the entire system, so they actually changed the viability dramatically of the farmlands below the dam. They also didn't think that the nutrients and the small animals and creatures in the food web that flow out of the Nile Delta into the surrounding ocean were the beginning of the food web for fisheries. So it actually completely changed the viability of the fisheries for an entire region. And this is what's known as systematically misleading thinking. So let's sit back and think about what we're doing, because it's a little more complex.
It definitely seems as if local scale solutions don't suffer from the same kind of, would you call it, systematically misleading thinking, right?
It's a little harder to make massive damage from not seeing a systematic effect from a local scale solution. Mm-hmm. And in most cases, not all cases, when we think about our local scale solution, if you're using less water at the local scale, for example, say because you're rainwater harvesting, or you're actually taking less, you're reducing your negative impacts on society, so it should be a positive outcome. But because it's only one property, the chances of making a dramatic failing are quite small. I'm not going to spend very long on this, except for one thing, getting back to Donella Meadows, which Michelle was talking about. The whole world is driven by feedback loops. The red box is talking about, well, we can analyse things locally, and later in the course, Michelle's going to take you through how to work out how your home scale solution works. That's our local simulations or local calculations. But they're affected, so it's a bottom-up process that'll have an effect on the whole system, as you can see here for the big blue arrows going upwards, or downwards actually, but upwards in scale. But throughout the system, they're feedback loops. So, if you're discharging less stormwater that's carrying contaminants to your local waterway is going to be healthy, have less blue-green algae outbreaks. So your system's feedback loop from that waterway is your waterway's healthier, your enjoyment of it, the viability of it even, is better, so you actually have a benefit in that respect. That's one example. So it's all about feedback loops as well. This slide I actually presented in Texas in 2010, where they were good enough to ask me to come and speak at a conference. And this is the impact of rainwater harvesting on water supply networks. And this is for the water supply engineer in a city that says, oh yes, but you have your rainwater supply on your house. It won't make any difference because the size of the small house service, the little pipe that comes into your house to supply your taps, and maybe even the small pipe in the street, which are called street mains, it's not going to really change much. Therefore, there's no benefit. There's no economic benefit. But remember, it's a cumulative and system. The benefits actually occur further downstream. So when you get down to the pressure reservoir, so in any water supply system, the flows to properties is actually managed and made resilient by these service or pressure reservoirs. The performance of that is completely different if you change the flows to that and the volumes. And obviously the pumps are working less and less intensely in that system, so they last longer, have to be replaced less often, they use less energy, and the bigger mains that are supplying water to that area that might have a number of rainwater harvesting systems actually last longer because the change in flows in them, and they leak less. So water supply involves leakage. So if your intensity of flow through your water pipes supplying parts of a city is less, there's a very large change in the potential for leakage, because leakage is driven exponentially by pressure. And of course your water treatment plant operates differently. It has to supply less water less intensely, so it lasts longer. Therefore, you don't need to replace it as often. It uses less chemicals, energy. Its operational costs are substantially less. You need to harvest less out of your local stream if it's coming from a weir, which is changing more pump flows. And your dam, so if your city's harvesting water where it falls, say rainwater harvesting, what actually happens is you leave less water in the dam when you're getting water locally, so that water's available for later on when you might need it. So it makes your water supplies more secure. Another word for secure is resilient. So it actually is ensuring that when bad times do come, there's less water, more water available in your storages and your aquifers underground when you really need it. So this is a really interesting systems effect where local storages throughout your city or your region actually work as a system with your big water supplies through storages like aquifers, weirs and dams, to actually produce the classic 1 and 1 equals 3 or 5 outcome.
It's a complement, really.
They create a complement, but a systems complement. So it's a value add in security and resilience is far greater than just adding them up. So this might be my final slide on systems, and sorry about potentially making it complex, but it is complex. Let's not hide from that. So the other question I answered at this Texas conference was the impact of rainwater harvesting on the watersheds or the stormwater management processes that a city might undertake. And we got to the same argument, and I'm talking to the diagram here is, so rainwater harvesting is harvesting some rainfall from your roof. And the city engineers would say, but that's not going to make much difference to the infrastructure I'm going to build in your street, street drainage infrastructure or stormwater management infrastructure, pipes and bits. But the road is actually a stormwater management device as well. But as the further you go downstream, you're making a big impact because you're changing the way the infrastructure operates. You're changing its chance of failure. So in a street, when you walk down it, you'll find that there's inlet pits where the street drainage system or the street stormwater system or the combined sewer, depending on what city you're in, allows water to enter the pipe system underground by these what we call pits. And when you think about the conversations about how big the pipes might be underground, and you see these little pits with little entries, if you thought about it a bit, you'd be saying those entries are quite small. So the success of your city's stormwater management system, if they just rely on drainage with the underground pipe system, is not the size of the infrastructure. It's the ability of water to get from the street and from properties into those pipes, which is via those drainage pits. So if the volume of flows, which we talked about earlier in these presentations, are less, the flows into those pits are less likely to fail, and the drainage system is more likely to be successful. So we're dramatically reducing the risk of failure, which is a difficult concept to understand, but that's what's happening. as you go further downstream into the bigger pipes, the flood retarding basins, the water quality devices, the change in volume of flows that accumulates if you've got many people saving water in your catchment, say by rainwater harvesting or permaculture, all sorts of methods you can do locally, is quite dramatic. So you're changing the quality in the stormwater and the volume, which actually changes the performance of these devices. It means the costs and the risks are greatly reduced. And obviously your urban streams and your waterways are far better off because of that. So rainwater harvesting does mitigate local flooding. If it supplements the capacity of drainage systems, so it's not working against them. The same as the water supply scenario, it's actually making the watershed management systems your city's using better off because it's helping them. It changes the transfer of contaminants to waterways. These contaminants are driven by volume and timing of flows. Obviously, contaminants don't end up in watersheds by magic. They're transferred by volume and timing of flows. If you're changing that, you're changing that problem. And of course, it reduces erosion and sedimentation in your waterways and improves the quality of water, say in a receiving water such as a bay or an estuary. So it's a systems effect. It's not really an argument about what happens just downstream from the property. It's an argument about what's the impact across the entire system. And
Peter,
thank you for your attention.
Yeah, no, I'm going to jump in though because I have just a thought. Our city is facing some increased environmental regulations in the last few years. And I know that they're grappling with this issue of the stormwater discharge into the river that guts through the city. And looking at spending, and have been spending quite substantial sums of money to put in some different types of stormwater treatment, retention ponds, et cetera, and et cetera. And it is curious. And I mean, your presentation really just hit on why. I do not believe that rainwater harvesting has even been proposed as an option to deal with the issue. They're far more focused on large centralized, stormwater basin solutions at the almost, I'd say, the outlet of the storm sewer before it gets into the river.
And remember early in the presentation I talked about city planners and that won't consider those options because they consider them to be unreliable, which is a systematically misleading assumption, because if you're trying to catch that problem at the maximum accumulation, which is maximum uncertainty about what the magnitude of the problem will be just before the water enters the river from the storm sewer, what happens? The risk of failure is maximised, and the cost of addressing that risk is orders of magnitude exponentially bigger than it would be if you addressed the problem upstream. But that's a really good point, Michelle, because it completely summarised the entire presentation. It depends on where you try and manage the problem. So there would be, I'm an engineer, and so have you, there would be very large economic and financial cost factors involved of only choosing a centralised solution. But I would suspect the city planners actually hadn't considered the system's effects, don't think local solutions will make any difference, and would have, with my experience working in Canada years ago, the local engineers wouldn't consider that either. So we hopefully more people consider the system's effects.
Yeah, well, and the kind of research you're publishing and these kind of conversations are really important, right?
Absolutely. I should come and look at your city
Yeah, you should. All right. Thank you, Peter.
Thank you.